Let us try to understand exterior angle. An exterior angle of a polygon is an angle outside the polygon formed by one of its sides and the extension of an adjacent side. One, 2, 3, 4, 5 are exterior angles of this polygon. We want to know the total measure of angles. 1 plus 2 plus 3 plus 4 and plus 5. Start at A. Walk along AB. On reaching B, you need to turn through an angle of 1 to walk along BC. When you reach at C, you need to turn through an angle of 2 to walk along CD. You continue to move in this manner until you return to side AB. You would have in fact made one complete turn. Therefore, 1 plus 2 plus 3 plus 4 and plus 5 equals 360 degrees. This is example of using angle sum of exterior angles for the polynomials. We have seen in last slide, angle sum of the exterior angles of a polynomial is 360 degrees. Now use this to calculate x in this example. Hence, x plus 90 degrees plus 50 degrees plus 110 degrees equals 360 degrees, or x plus 250 degrees equals 360 degrees. Hence, x equals 110 degrees. In this example, we will calculate number of sides for regular polygon. We know angle sum of exterior of a regular polygon is 360 degrees. In regular polygon, we have all sides making equal exterior angle. Hence, number of sides can be calculated. It is measures as total angle divided by measure of each angle. Hence, number of side is 8. Here, we have to find value of x. We know that sum of exterior angles of a polygon is 360 degrees. Hence, 125 degrees plus 125 degrees plus x equals 360 degrees, or 250 degrees plus x equals 360 degrees, or x equals 360 degrees minus 250 degrees equals 110 degrees. Here, we have to find value of x. We know that sum of exterior angles of a polygon equals 360. So, 70 degrees plus x plus 90 degrees plus 60 degrees plus 90 degrees equals 360 degrees, or 310 degrees plus x equals 360 degrees, or x equals 360 degrees minus 310 degrees equals 50 degrees. We have to find measure of each exterior angle of regular polygon. Since 9 sides of a polygon has 9 angles, and we know that sum of exterior angles of a polygon equals 360. So, 9 exterior angles equals 360 degrees, or 1 exterior angle equals 360 degrees divided by 9 equals 40 degrees. For 15 sides, 15 exterior angles equals 360 degrees, or 1 exterior angle equals 360 degrees divided by 15 equals 24 degrees. Here, exterior angle is given, and we have to find number of side of regular polygon. We know that number of angles of a polygon equals number of sides, and we know that sum of exterior angles of a polygon equals 360, and measure of each angle equals 24 degrees, or number of exterior angles equals 360 degrees divided by 24 degrees equals 15. Hence, number of sides equals 15. Here, we have to find number of sides when interior angle is given. Here, each interior angle equals 165 degrees. Let us learn to find exterior angle when interior angle is given. As we know how to find number of side when exterior angle is given. But here, we are given interior angle, hence we first need to know exterior angle. In this diagram, you can see exterior angle is equal to 180 degree minus interior angle, and vice versa. Hence, each exterior angle equals 180 degrees minus 165 degrees equals 15 degrees, as measure of each exterior angle equals 15 degrees. So, number of sides equals 360 degrees divided by 15 degrees equals 24. Hence, number of sides equals 24. Here, we have to see whether a given exterior angle can be for a regular polygon. We need to see if number of sides calculated is whole number or not. Lieutenant, just see in this question. Since number of sides of a polygon is equal to 360 degrees divided by each exterior angle, hence, number of sides of given polygon equal to 360 degrees divided by 22 degrees, which is equal to 16.36. Since answer is not a whole number, thus, a regular polygon with measure of each exterior angle as 22 is not possible. Hence, Answer is no. Now, here, we will check if 22° can be interior angle of a regular polygon or not. Here, each interior angle equals 22 degrees. Hence, each exterior angle equals 180 degrees minus 22 degrees equals 158 degrees. Hence, number of sides equals 360 degrees divided by 158 degrees equals 2.27. Since answer is not a whole number, thus a regular polygon with measure of each interior angle as 220 is not possible. Hence, answer is no. Here, we have to find minimum interior angle possible for a regular polygon. An equilateral triangle is a regular polygon having three sides with the least possible minimum interior angle. As the regular polygon with minimum sides can be constructed with three sides at least, since sum of the interior angles of a triangle is equal to 180 degrees. Hence, each interior angle equals 180 degrees divided by 3 equals 60 degrees. In this question, we have to find maximum exterior angle possible for a regular polygon. Each exterior angle of a regular polygon is equal to 360 divided by number of sides in the polygon. Hence, exterior angle will be maximum if number of sides will be minimum. Now, regular polygon with minimum side is equilateral triangle, and hence maximum exterior angle possible is an equilateral triangle. If 360 is divided by 3, we get 120. Here, we will learn about trapezium. Trapezium is a quadrilateral with a pair of parallel sides. Let us see some examples below. Here, you can see this and this are parallel, hence this is trapezium. Here, you can see this and this are parallel, hence this is trapezium. Here, you can see this and this are parallel, hence this is trapezium. Here, you can see sides are not parallel, hence this is not trapezium. Here, you can see sides are not parallel, hence this is not trapezium. Here, you can see this has 5 sides. 1, 2, 3, 4, 5. Hence this is not quadrilateral. Hence, this cannot be trapezium, as trapezium is quadrilateral. In this topic, we will learn about kite. Kite has 4 sides, and hence, this is an quadrilateral. Here, we have 2 adjacent sides of equal length. Let us see some example of kites below. This and this are equal. This and this are equal. Hence this is kite. This and this are equal. This and this are equal. Hence this and this are equal. This and this are equal. Hence this is kite. Here you can see. This has 5 sides. Hence not a kite. Here 4 side. But not adjacent. Sides are equal. Here, only 2 adjacent sides are equal. Other 2 are not. Hence this is not kite. Here, we will learn about parallelogram. This is quadrilateral, whose opposite sides are parallel and equal. Let us see some examples of parallelogram below. Here, this and this are parallel and equal. Here, this and this are parallel and equal. Hence this is parallelogram. Here, this and this are parallel and equal. Here, this and this are parallel and equal. Hence, this is parallelogram. Here, this and this are parallel and equal. Here, this and this are parallel and equal. Hence, this is parallelogram. Here, you can see this and this is parallel but not equal. Also this is not parallel. Hence this not parallelogram. Here, this and this sides not parallel. Hence, this is not parallelogram. This has 6 sides. Hence, this is not parallelogram. Here, we can see various elements and its properties for a parallelogram. The opposite sides of a parallelogram are of equal length. Hence, AD equals BC and AB equals CD. The opposite angles of a parallelogram are of equal measure. Hence, angle A equals angle C and angle B equals angle D. The adjacent angles in a parallelogram are supplementary, meaning A plus D equals 180 and B plus C equals 180. Here, we have to find perimeters of this parallelogram. In a parallelogram, the opposite sides have same length. Hence, PQ equals SR and QR equals PS. We know that perimeter of this parallelogram is PQ plus QR plus RS plus SP. Putting the value of sides, we get perimeter as 38 centimeters. Here, we have to prove that if AC is the diagonals of the parallelogram, then angle 1 equals angle 2 and angle 4 equals angle 3. Here we can see diagonal AC divide parallelogram ABCD into two triangles ABC and CDA. Here, remember concept of congruency of triangles. Here triangle ABC and triangle CDA are congruent, as side AB equals side CD and side BC equals side DA, and angle ABC and angle CDA are equal. Hence this is congruent by SAS rule. Let us recap the SAS rule. Here, you can see SAS rule. SAS side angle side, and means that we have two triangles where we know two sides and the included angle are equal, are congruent. Hence here, this and this triangles are congruent. Since triangle ABC and triangle CDA are congruent, hence angle 1 equals angle 2 and angle 4 equals angle 3. In this figure, we will use parallelogram properties to find x, y, and z, angle B, and angle SR, opposite angle of parallelogram, and hence they are equal. So, x equal angle B equal 100 degree angle B, and angle E are adjacent angle and are supplementary. So, Z plus B equals 180. Hence, Z equals 180 minus 100 equals 80. Angle Z and angle Y are adding up to 180 on straight line. Hence, 80 plus Y equals 180, or Y equals 180 minus 80 equals 100 degree. Here, we have to prove diagonals of a parallelogram bisect each other at the point of their intersection. That means diagonals AC and BD divide itself in equal parts at center O, or AO equals OC, and DO equals OB, applying ASA space, that is angle, side, angle criterion. It is easy to see that Triangle AOB is congruent to triangle AOB. This gives AO equals CO and BO equals DO. In this example, we will use concept learnt for parallelogram diagonals. We have seen in previous slide. Diagonal bisect itself at center point. In this example, we are given OE equals 4. Hence, OP is also 4, as diagonal bisect itself at center point. Hence, PE equals PO plus OE equals 4 plus 4 equals 8. Now, HL equals 5 times P. Hence, PE equals 5 times 8 equals 40. And HO equals half of HL equal 40 divided by 2 equals 20 centimeters. Question 1. Here, knowledge of parallelogram and its diagonals properties are tested. In parallelogram we have learnt that a parallelogram is a quadrilateral whose opposite sides are parallel and equal. Here, you see, AB and DC are parallel and equal. Similarly, AD and BC are parallel and equal. Also, IC and BD bisect each other at O. Hence AD equals BC. Angle DCB equals angle DAB. Since opposite angles of a parallelogram are equal, OC equals OA. Since diagonals of a parallelogram bisect at center, angle DAB plus angle CDA equals 180 degree. As adjustment angles of parallelogram is 180 degree. Question 2a. Here, knowledge of parallelogram and its diagonals properties are used. In this question, we have to find x, y, and z. We can see y equals 100 degree, since these are opposite angles of a parallelogram. Now, x plus 100 equals 180, since these are adjacent angles of a parallelogram. Hence, x equals 180 minus 100 equals 80. Also, x equals z equals 80, since they are opposite angles of a parallelogram. Thus, x equals 80, y equals 100, and z equals 80. Question 2a. Here, knowledge of parallelogram and its diagonals properties are used. In this question, we have to find x, y, and z. We can see y equals 100 degree, since these are opposite angles of a parallelogram. Now, x plus question 2b. Here, knowledge of parallelogram and its diagonals properties are used. In this question, we have to find x, y, and z. Here, we can see 50 plus x equals 180, since both are adjacent angles of a parallelogram. Hence, x equals 180 minus 50 equals 130. Now x equals y equals 130, since both are opposite angles of a parallelogram. Now x equals z equals 130, as these are corresponding angle. Question 2c. Here, knowledge of parallelogram and its diagonals properties are used. In this question, we have to find x, y, and z. Here, we can see x equals 90 degree. This is opposite angles of crossing sides. In this triangle, sum of all angles are 180 degree, since both are adjacent angles of a parallelogram. Hence, x plus y plus 30 equals 180 degree, or 90 plus y plus 30 equals 180, or y equals 60. Also, y equals z equals 60, as y and z are alternate angles of diagonals. Question 2d. Here, knowledge of parallelogram and its diagonals properties are used. In this question, we have to find x, y, and z. Here we can see z equals 80, as this and this angle is corresponding angle. Y equals 80, as they are alternate angles of parallelogram. Now, x plus 80 equals 180, as per the properties of adjustment angle of parallelogram. Now, let us recap properties of parallelogram. This is equal to this. This is equal to this. This angle is equal to this angle. This angle is equal to this angle. This angle plus this angle is 180 degree. This angle is equal to this angle. Here, this angle is equal to this angle. This angle is equal to this angle. This angle is equal to this angle. And question 2e. Here, knowledge of parallelogram and its diagonals properties are used. In this question, we have to find x, y, and z. Here, we can see y equals 112, as their opposite angles are equal in a parallelogram. Now, sum of angles of this triangle is 180 degree. Hence, 40 plus y plus x equals 180, or 40 plus 112 plus x equals 180. Hence, x equals 28. Also, z equals x equals 28, as they are alternate angles of this diagonals. Question 3. Here, we have to check, with given condition, can a quadrilateral ABCD be a parallelogram or not? First condition, D plus B equals 180. With this condition, it is possible that ABCD are parallelogram. If other condition of parallelogram is fulfilled, 2AB equals DC equals 8 centimeters and AD equals 4 centimeters and BC equals 4.4 centimeters. With this condition, it is not possible that ABCD are parallelogram, as here AD and BC are not equal. 3A equals 70 degrees and C equals 65 degrees. With this condition, it is not possible that ABCD are parallelogram, since in parallelogram, opposite angles must be equal. Question 4. Here, we have to draw a rough figure of a quadrilateral that is not a parallelogram, but has exactly two opposite angles of equal measure. ABCD is a figure of quadrilateral that is not a parallelogram, but has exactly two opposite angles, that is, B equals D of equal measure. It is not a parallelogram, because A not equal to C. Question 5. Here, we have to find the measure of each of the angles of the parallelogram. When measures of two adjacent angles of a parallelogram are in the ratio of 3 each to 2. Let the measures of two adjacent angles A and B be 3x and 2x, respectively, in parallelogram ABCD. Now, A plus B equals 180, as sum of adjacent angles of parallelogram is 180 degree, or 3x plus 2x equals 180, or x equals 36 degree. Hence A equals 3x equals 3 times 36 equals 108, and B 2x equals 2 times 36 equals 72. We know that opposite angles of a parallelogram are equal. Hence, A equals C equals 108 degree and B equals D equals 72 degree. Question 6. Here, we have to find the measure of each of the angles of the parallelogram. When two adjacent angles of a parallelogram have equal measure, let ABCD be a parallelogram. Now, sum of adjacent angles of a parallelogram equals 180. Hence, A plus B equals 180. Now given that two adjacent angles are equal, hence A and B are equal. Hence equation become 2 into A equals 180, or A equals 180 divided by 2, which is 90 degree. Also, 90 plus B equals 180, as sum of adjacent angles of parallelogram is 180 degree, or B equals 180 minus 90 equals 90. Also, A equals C equals 90 and B equals D equals 90, as opposite angle of parallelogram are equal. Question 7. Here, we have to find X, Y, and Z. Here, you can see HOPE is a parallelogram, and HP is diagonal. Hence Y is equal to 40, as they are alternate angle of diagonal HP. Now this angle O is 180 degrees minus 70 degrees equals 110 degrees. Hence angle E, which is X, is 110 degree. Now, X plus H equals 180, as they are adjacent angle of parallelogram, or X plus 40 plus Z equals 180, or 110 plus 40 plus Z 180 equals 180, or Z equals 180 minus 150 equals 30 degree.